Hey, what's up, peeps? In this video, we are going to express the arrangement of electrons in atoms through what are called electron configurations. So, as an extension from our last video, you might recall that we introduced the idea of orbitals. And here on your screen on the left is a representation of the electron cloud of a hydrogen atom. One electron flying around in a spherical three-dimensional region of space. Now, it's really tricky to describe three-dimensional regions of space. And so electron configurations, which is what you see on the right, are a way to very quickly describe where the electrons are without having to spend all the time to represent it in three dimensions. Your goal is to eventually get comfortable translating between what you see in an electron configuration to what it might look like in a three-dimensional region of space. So first, it's important to recognize that the Heisenberg uncertainty principle states that it is impossible to determine simultaneously both the position and the velocity of an electron or any other particle. That's the driving idea behind orbitals in the first place. Because this electron here is flying around so fast, you can't ever simultaneously pinpoint where it is and how fast it's going. And so instead of trying to do that, we just describe where most likely we would find it by using an orbital to describe the region of space where we could find it. It's going to be somewhere in here instead of pinpointing the exact location and velocity at any given time. Now, there are a few rules that will guide us as we create these electron configurations, the first of which is what's known as the Pauli exclusion principle. And this states that no two electrons exist in the exact same orbital and spinning the exact same direction. Electrons are negative, like charges repel. How are we going to get two negative like charges in the same space? Well, they're going to have to be spinning in opposite directions. And because there's only two fundamental ways to spin, clockwise and counterclockwise, you can only ever get two electrons in the same orbit. More on what this is going to look like in electron configurations in a minute. 2. The Aufbau principle states an electron will occupy the lowest energy orbital that can receive it. This one makes sense to me. I like to use as little energy as possible, and the Aufbau principle just reinforces that. Electrons, they don't want to spend any more energy than they have to. Lowest energy level first. Again, more on this in just a minute. And then 3. Huns Rule states that orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and all electrons in singly occupied orbitals have the same spin. Whew, now that's a mouthful. One way to think about Huns Rule is think about a house that has 3 equal rooms, and if you have siblings, this analogy might make a lot of sense. I've got a lot of siblings, and so if I have the opportunity to get away from my siblings and exist in my own room, boom, there I am. I'm going to do that. And if my brother or sister comes along, I'm going to say, hey, go to your own room, hang out in your own space. We'll be happier that way, right? And then my other sibling comes along. We've got the room. Hey, go to your own room, hang out in your own space. But then, right, next bro or sis comes along and there's no space for them to have their own room. If you're gonna share the same space with a sibling, you don't want to look at their face, am I right? And so if you have them face the opposite direction, you can hang out in the same room, right? I don't want to look at your face, just face the other direction. Electrons are kind of the same way. They're like charges, they don't like hanging out in the same space, and the only way that that's possible is if they're spinning in opposite directions. This continues until all of the rooms are full. Remember, you can only fit 2 electrons, in this case 2 siblings, in any given room, because there's only fundamentally 2 ways to spin, clockwise and counterclockwise. So basically, we're going to think about the Heisenberg uncertainty principle and some of those rules to describe what's known as an atom's electron configuration. Now, there are a few different ways you can do this. In this video, we're going to start with what's known as the orbital notation configurations. Basically, how do you go from this 3D representation of the electrons of an atom into this easy to write orbital notation electron configuration? So let's get to it.